All right, now that last video was kind of long, so we're gonna cut these down into smaller segments. So let's try this out. In this video, all we'll do today is find the domain of a rational function. Join me, let's figure this out together. All right, so let's take a look at a general rational function. Remember, for a rational function, the root here is ratio. Okay, I can make a ratio of something, and here I am making a ratio of a polynomial function. So both P and Q are polynomial functions. Now, I'll tell you right now that the domain for all rational functions is all real numbers. All real numbers. So there you go. This is a really short video then, right? Almost. See, our denominator, our q, that polynomial function cannot be equal to 0, right? That would be an undefined ratio. So we have to figure out where our denominator is going to be equal to 0, because that will create a graph that you haven't seen before. Okay, so let's take a look at these two examples. Remember, our domain is all real numbers. Not done though, we need to check our denominator. We need to check this polynomial function so that it's not equal to 0, right? So let's check this one. We're going to make sure, so let's check this one. Let's check our denominator where it is equal to 0. So just grabbing your denominator, I'm going to write x plus 5. Let's see where it's equal to 0. And this one is not too shabby at all. We'll see that x will be, our denominator will be equal to 0 when x is negative 5. So our domain is all real numbers except when x is equal to negative 5, or you might see the notation of, in your bracket notation of an x, such that x, we cannot let this equal to negative 5. Okay, so there's A. What about B though? Okay, let's step it up a notch. Notice that for my denominator here, well, first our domain, we know that our domain is all real numbers except somewhere, right? So let's see where that is. Let's pretend that's an E. There we go. So using our denominator, right, we have x squared minus 4 equal to 0. Okay, and even there, this one's not too bad. I'm going to add 4 to both sides. Notice I get x squared equal to 4. Now don't forget this next step. When I take the square root on both sides, I'm going to get two answers. X is equal to either positive 2 or negative 2. Okay, remember we did that earlier when we were solving quadratics. So here I actually have two answers. My x cannot be equal to 2 or negative 2. So that's when I would get a 0. Okay, let's just double check that part in case you don't remember. If I substitute a 2 in here, I get 2 squared, which is 4, and then minus 4, I get 0. When I put a negative 2 in here, remember that is negative 2 squared minus 4. Simplify that, I get 4 minus 4 again, which is equal to 0. So here I have two answers, except where x is equal to 2 or negative 2. Okay, and if you're using the bracket notation, let me just switch colors here. Then I'll say, oops, let's say my domain is all real numbers such that x does not equal, because I don't want it to be 2 or, and x cannot be equal to negative 2. Close bracket. Sorry, I kind of ran out of space there. Okay, what about these next two? Here I have, in C, I have x to the third over x squared plus 1. still start off the same way, that my domain is all real numbers, except where? Well, let's see what happens with this denominator. Let me see. So x squared plus 1, I want to see when it'll be equal to 0. So x squared, I'm going to subtract 1 on both sides, so I get -1. But notice that if I try to take the x squared, if I try to take the square root, you haven't messed with complex numbers or imaginary numbers yet, which are outside the realm of the real number system. So I can't keep going. I can't keep solving this one for real number values. So this is kind of good. My domain is right here, all real numbers, since I can't keep going. What about here? So same thing, my domain is all real numbers for D, and I'm only looking at the denominator portion. So the domain is all real numbers. And here I want to see when 4 is equal to 0. When is 4 equal to 0? Well, I can't do anything with this. There's nothing for me to work out. There's nothing for me to do. So guess what? My domain is right here. I don't have to solve anything else. It's just domain is all real numbers. All right, what about this one here? And I already just wrote it down because I know that's how I was going to start. My domain is all real numbers. Let's look for that denominator. So solving for my denominator equal to 0, I have x minus 1. When is it equal to 0? When I add 1 to both sides, x is equal to 1. So just like before, all real numbers except for when x is equal to 1. Except x equal to 1, or once again in brackets, I'm going to put it here. Okay, all real numbers of my x such that x does not equal to 1. I don't want that. Now, you might be looking at this and saying, hey, but I can simplify this. I can do something to it. Those of you that caught it, let's go ahead and see what's happening here. So if I expand this, and I'll use a different color here, this is the same as saying x plus 1, x minus 1. You might have caught that this is a difference of squares, which is the same as having this x minus 1 as your denominator. So this whole thing, okay, this denominator, if you were simplifying it, would cancel out, and you're left with just x plus 1. Now, notice that here my domain is all real numbers. It's everything, right? But I'm saying that here it's everything except when it's x is equal to 1. That's because these are still different functions, okay? Later on we'll talk about what happens when I graph this. This is actually, if you've already gone to your classes, they might have talked to you about creating a hole in your graph, okay? So let's do some practice ones where you tell me the domain. Go ahead and try these two problems. Now I'll show you how to do them in 3, 2, 1. Okay, so here are the answers. Let's break it down a little bit because there's a lot happening, right? So in number 1, remember we cared about our denominator, so we want to see when this whole thing will be equal to 0, but we notice that it's a factored quadratic, so we need to split it up. So either x minus 2 is equal to 0 or x plus 4 will be equal to 0. Solving that, we see that we get two different x's here when it would be equal to 0, when it's 2 or -4. So our domain is all real numbers except where x is -4 or 2, or we can say it like this, okay? So all real numbers such that x does not equal -4 or 2. All right, now let's look at the second example. I really like this one. Notice that our denominator is a difference of cubes. So we need to split it up, right? Not only that, notice that, you know, we have two things multiplying, and we're trying to see when this whole thing will be equal to 0. So I'm going to do a split again. because either we need to be careful when either this is 0 or when this is 0. So you have either x minus 2 equal to 0, which we solve for, so we quickly get x equals 2. Now, when we look at the one on the right, though, I can't keep factoring that. That's already as simple as it's going to get. If you remember, when you're messing with your quadratics, you can look at the determinant, which is what I did here, to see how many solutions I can get. And I see that this is less than 0, right? When I put in b squared, right? So it's 2 squared minus 4ac. So minus 4 times 1 times 4. That's less than 0. So that means that I get two complex solutions. Remember, complex or like non-real numbers, they're not in the real number system. So I don't have any real numbers here to mess with. So I don't take this into account. And I only get one exception here for my domain. So I don't worry about this. I only care about this one. So my domain is all real numbers except where x is equal to 0. There you go. Okay, so that's where we'll end for today. Hopefully you like the shorter format of the videos. It will help you target exactly what you need instead of searching through a 40-minute one like last time. So next time we'll be graphing the rational functions. Until next time.